Hello, in this lecture we find out the area of the green shape using two different methods. In the drawing we have three identical squares. You know that one side of this square is equal to 2. Therefore all the other sides of all the other squares must be equal to 2 because they are identicals. And we also have this green shape. This is a right angle, therefore the green shape, it is a right triangle, so we have to find out the area of this green right triangle. Our task is to find out the area of this green right triangle. So first of all, I will define two concepts. The first concept is the Cartesian coordinate system. The second concept is the slope of a straight line. So, what is the Cartesian coordinate system? The plane has two dimensions, the horizontal dimension and the vertical dimension. In the Cartesian system, the horizontal dimension is represented by the x-axis and the vertical dimension is represented by the y-axis. The intersection point between y-axis and x-axis, it is this point, and it is defined as the origin. That is to say, it is the starting point of both axes, the x-axis and the y-axis. So the coordinate of x of the origin, this point, equals to 0, and the coordinate y of this point must be also equal to 0. So we define the name of this point as O, and every point in the plane is represented by two numbers. The first number represents the horizontal distance of the point from the origin. For example, we take this point A. The horizontal distance of this point A from the origin is this distance. So it is minus 3, minus 0. So the coordinate x of this point A equals to minus 3. And the second number represents the vertical distance of point A from the origin. The vertical distance of point A from the origin is this distance. This is really minus 1, minus 3, this is minus 1. So the coordinates of point A are minus 3 and minus 1. So the second concept is the slope of a straight line. In geometry, the slope of a straight line describes the intensity of its stiffness. A large absolute value of a slope indicates a large steepness, and a slope is defined as the ratio of the vertical difference between 2 points on the line to the horizontal difference between those 2 points. This is a straight line. The coordinates of point A are x2 and y2. Likewise, the coordinates of this point B are x1 and y1. So the slope of this straight line, the slope is represented by the letter m, so the slope m of this straight line equals to the ratio of the vertical difference between those 2 points. It's actually y2 minus y1 over the horizontal difference between those 2 points. It's actually x2 minus m1. So the slope m of this straight line equals to y2 minus y1 over x2 minus x1. The slope of a straight line is also the tangent of the angle that the straight line makes with the positive x-axis. This is the positive side of x-axis and this is the negative side. This is a straight line, and the slope of this straight line, m, equals to the tangent of the angle that this straight line makes with the positive x-axis, that is to say, theta. So the slope of this straight line, m, equals to tangent theta. Again, the angle is the angle that it is the angle that it is the angle that the straight line makes with the positive x-axis, that is theta. So the slope m of this straight line equals to tangent theta. So we have two different equations for the slope. This is the second equation, that the slope m equals to tangent theta. The first equation, the slope m equals to the ratio between the vertical difference, that is y2 minus y1, over the horizontal difference, that is x2 minus x1. If a slope of a straight line is a positive slope, then the straight line goes up from the left side to the right side. Likewise, if the slope of a straight line is a negative slope, then the straight line itself goes down from the left side to the right side. It falls from the left side to the right side. And finally, if the slope of a straight line is 0, then the straight line itself is parallel to the x-axis, like this straight line. So actually, the slope of a straight line indicates how many units the line goes up or down. For each unit it moves right. For example, this is the straight line y equals to 3x. The slope of this straight line is 3. So what is the meaning of the slope? For each unit that the straight line goes to the right side, here it goes 1 unit from point 1 to point 2, it goes up 3 units. That is to say, it rises from point 3 to point 6. So for each unit that this straight line goes to the right side, it goes up 3 units up. Okay, and therefore the slope of this straight line equals to 3, because for each unit that it goes to the right side, it goes up 3 units to the up, it goes 3 units up. The greater the slope of the straight line, the steeper it is. And again, the greater the slope of the straight line, the steeper it is. For example, here we have, this is the blue straight line. The slope of this blue straight line, m equals to 3. Likewise, we have, this is the red straight line. The slope of the red straight line is 1/3. And because of the fact that the slope of this straight line is greater than the slope of this red straight line, it is steeper than the red straight line. Here, the blue straight line is steeper than the red straight line. It means that it is farther to the x-axis than the red straight line. So you can see that the blue straight line is farther to the x-axis than the red straight line. Right? But its slope is greater than the red straight line, and the greater the slope, the steeper the straight line. Okay. So, in the next step, we will create the Cartesian coordinate system in our drawing. We define this straight line as the x-axis. And the vertical, this vertical straight line is the y-axis. This is the positive part of the x-axis, and this is the negative part. Likewise, this is the positive part of y-axis, and this is the negative part. And the intersection point between x-axis and y-axis, this point is defined as the origin. The origin is the starting point of both axes. So we define this point, the origin, as O. So the coordinates of point A are 0 and 0. The coordinate x equals to 0, and the coordinate y also equals to 0, because point O is the starting point of both axes. So we define this point as point A. What are the coordinates of point A? The coordinate x of point A is the horizontal distance of point A from the origin. The horizontal distance of point A from the origin is this distance. Okay? But this is the negative part of x-axis. So from point O, that is 0, we will go 2 plus 2 plus 2, 6 units to the left side. So the coordinate x equals to -6, because this is the negative part of x-axis. coordinate x equals to minus 6. What about coordinate y of point A? And coordinate y of point A is the vertical distance of point A from the origin. The vertical distance from point A from the origin is this distance. This is to say it is 2. And because of the fact that this part is the positive part of y-axis, it is equals to plus 2. And down is the negative part. So the coordinate y of point A equals to 2. So total the coordinates of point A are minus 6 and 2. Likewise, we define this point, that is the vertex of this green right triangle, as point B. We don't know the coordinates of point B, therefore we define the x coordinate of point B as x1 and the y coordinate of point B as y1. In the next step, we'll find out the slope of this straight line BO. What is the slope of this straight line BO? So first of all, the diagonal of this square bisects the angles of this square. So each half must be equal to 45 degrees in size. The coordinate x is perpendicular to the coordinate y, therefore this is a right angle. And the angle that this straight line BO makes with the positive x-axis equals to 45 degrees plus 9 degrees, this is 135 degrees. So theta equals to 135 degrees. And the slope of this straight line BO equals to tangents 135 degrees. The slope M of the straight line BO equals to tangents 135 degrees. The angle is the angle that the straight line BO makes with the positive x-axis, that is 135 degrees. So the slope M of this straight line BO equals to tangents 135 degrees. Tangents 135 degrees equals to minus 1. So if you found out that the slope of the straight line BO is equal, the slope M equals to minus 1. In the next step, we will find out the equation of this straight line BO. Point O, the origin, it is definitely located on the straight line O, on this straight line BO. And we know that the slope of this straight line BO equals to minus 1. We have a general formula for the function of any straight line. The formula of any straight line is as follows: y minus y1 equals to m, m is the slope of the straight line, times x minus x1. Here x1 and y1 is the point on the straight line itself. And because of the fact that point O, the origin, is located on the straight line BO, x1 equals to 0 and y1 equals to 0. And the slope of this straight line BO is minus 1, m equals to minus 1. So we have all the data that is needed in order to find out the equation of this straight line BO. Just have to put the data of this straight line in this formula for a straight line. In this way we find out the equation of this straight line BO. We'll do it now and we get that y minus y1. y1 is 0, so it is y minus 0 equals to m. M is minus 1 times x minus x1. x1 is also 0. So in total, we found out that the equation of the straight line BO is y minus 0 equals to minus 1 times x minus 0. Y minus 0 is y, and it equals to minus 1. X minus 0 is x, so y equals to minus 1 times x. So y equals to minus 1 times x is minus x. So in total, we found out that the equation of the straight line BO is y equals to minus x. Because of the fact that the slope of this straight line BO is a negative slope, the function, the straight line, goes down from the left side to the right side. In the next step, we'll find out the slope of this straight line AO. Because of the fact that those 2 points are located on the straight line AO, we use the formula that says that the slope of a straight line is the vertical difference between 2 points over the horizontal difference between 2 points. That is to say, we use the formula that says that the slope of a straight line equals to the vertical difference, that is y2 minus y1 over the horizontal difference, that is x2 minus x1. So I'll copy the straight line AO here. The coordinates of point A are minus 6 and 2. And the coordinates of point O, the origin, are 0 and 0. We define the coordinates of point A as x2, y2. That is to say, the coordinate x of point A is minus 6 equals to x2. So x2 equals to minus 6. Likewise, the coordinate y of point A is 2, so y2 equals to 2. Likewise, we define the coordinates of this point O, that is the origin. We define the coordinate x as x1, that is to say x1 equals to 0. And we define the coordinate y of this point O, that is the origin, as y1. So y1 also equals to 0. Now we just have to put the data of this straight line AO inside this general formula for a slope. In this way we find out the slope of this straight line AO. So the slope of the straight line AO, the slope M, equals to y2 minus y1. y2 is 2 minus y1. y1 is 0, so it is y2 minus y1 is 2 minus 0 over the horizontal difference, that is x2 minus x1. x2 is minus 6, minus x1 is 0. So in total, we found out that the slope of this straight line AO equals to 2 minus 0 is 2 over minus 6 minus 0 is minus 6. So here we divide both the numerator and the denominator of this number by 2, so 2 over 2 is 1 and minus 6 over 2 is minus 3. So we found out that the slope of the straight line AO equals to minus third. The slope of this straight line AO equals to minus third. So, and because of the fact that the slope of this trend line AO is a negative, it goes down from the left side to the right side. The absolute value of the slope of this straight line BO is the absolute value of -1, that is 1. The absolute value of this the absolute value of the slope of this straight line is the absolute value of -1/3, that is third. So the absolute value of this, the absolute value of this straight line, of the slope of this straight line, is greater than the absolute value of the slope of this straight line, and therefore this straight line, if a greater slope, is steeper than this straight line. What it means that it is steeper, this straight line is steeper than this straight line. That is to say, it is farther from the x-axis. This straight line is farther from the x-axis than this straight line. Why? Because the absolute value of this slope is greater of this. The absolute value of the slope of this straight line is greater than the absolute value of the slope of this straight line, and therefore this straight line is steeper than this straight line. Okay. We define the slope of this straight line AB as M2. We don't know the value of the slope, so we define the slope of this straight line AB as M2. The straight line AO is perpendicular to the straight line AB. Again, those two straight lines are perpendicular to each other because of the fact that at the intersection point they create a right angle. And we have rule 12 that says that if two straight lines are perpendicular to each other, then the product of their slopes is equal to -1. So repeat quickly on rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, like in this drawing, and we know that the slope of the first line is M1, the slope of this straight line is M1, and the slope of the second line is M2. The slope of this straight line is M2. Then the following equation is true, that M2 times M1 equals to -1. Repeat again, according to this rule 12, if two straight lines are perpendicular to each other, like in our drawing, then the product of their slopes equals to -1. That is to say, M1 times M2 equals to -1. We can definitely implement the rule 12 in our drawing. Why? Because of the fact that the straight line AB is perpendicular to the straight line AO. And the slope of this straight line AB is M2, the slope of this straight line AO is -1/3. So according to rule 12, the product of their slopes equals to -1. That is to say, M2 minus -1/3, M2 times -1/3 equals to -1 according to rule 12. And again, according to rule 12, because of the fact that AB is perpendicular to AO, the product of their slopes must be equal to -1. That is to say, M2 times -1/3 equals to -1. Repeat again, according to rule 12, the product of the slopes of AB and AO equals to -1. Here we multiply this equation by -1. In this side of the equation we have -M2 over 3 times -1 is M2 over 3. And it is equal to -1 times -1 is 1. So So in total, we found out that m2 over 3 equals to 1. Here we multiply this equation by 3. And finally we get that m2 equals to 3 times 1 is 3. So in total, we found out that the slope of this straight line AB equals to 3. And because of the fact that the slope of this straight line is positive, it goes up from the left side to the right side. Exactly as I presented to you a couple minutes ago. So in the next step, we'll find out the equation of this straight line AB. Because of the fact that we know that the values of point A and the slope of this straight line M2 is 3, we can easily find out the equation of this straight line AB according to the formula that I've already presented to you. The general formula for the equation of any straight line is as follows: y minus y1 equals to m times x minus x1. Point A is located on the straight line AB. So x1 equals to minus 6. And y1 equals to 2. And we already found out that the slope of this straight line AB is 3, so m equals to 3. So we have all the data that is needed in order to find out the equation of this straight line AB. The equation of the straight line AB is as follows: y minus y1, y minus y1. y1 is 2, so it is y minus 2 equals to m. M is 3. Inside the bracket we have x minus x1. So x1 is minus 6. So it is x minus minus 6. So in total, we should find out that y minus 2 equals to 3 times x minus minus 6. So x minus minus 6 is x plus 6. So in total, we should find out that y minus 2 equals to 3 times x plus 6. Again, y minus 2 equals to 3 times x plus 6. So y minus 2 equals to 3 times x is 3x. And 3 times 6 is 18. So in total, we should find out that y minus 2 equals to 3x plus 18. Here we will add 2 to this equation. And we get that y equals to 3x and 18 plus 2 is 20. In total, we should find out that the equation of this straight line AB is y equals to 3x plus 20. And we have the rule that says that if a point is located on a straight line, then the straight line must satisfy the equation. And if a point is located on the straight line, then the point must satisfy the equation of the straight line. I'll repeat again. According to the rule, if a point is located on a straight line, then the point must satisfy the equation of the straight line. For example, this is point A, this is located on the straight line AB. Therefore, point A must satisfy the equation of the straight line AB. That is to say, if we substitute x by minus 6 and y by 2, the left side of the equation will be equal to the right side of the equation. So y equals to 2, and actually it is 2 in this equation, y minus y1 equals to m times x minus x1. So if we take this point B, that is located on the straight line AB, and we substitute x by x1 and y by y1, then the left side of the equation will be equal to the right side of the equation. So we do it now and get that actually we can also take this point. Point A is located on the straight line AB, therefore point A must satisfy this equation, y equals to 3x plus 20. So y equals to 2, so 2 equals to 3x, x is minus 6, so 3x is 3 times minus 6, that is minus 18, and minus 18 plus 20 is 2, so 2 equals to 2, okay? That is to say, point A satisfy the equation of this straight line AB because of the fact that point A is located on the straight line AB. Likewise, point B is located on the straight line AB, therefore point B must satisfy this equation. That is to say, if we substitute x by x1 and y by y1, then the left side of the equation will be equal to the right side of the equation. So we substitute x by x1 and y by 1 by y1 in this equation, and we get that according to equation 1, y1 equals to 3 times x1 plus 20. And again, according to equation 1, y1 equals to 3x1 plus 20. Likewise, point B is also located on the straight line BO. Therefore, point B must satisfy the equation of the straight line BO. That is to say, y1 equals to minus x1. So we have two equations for y1. Therefore, we get equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x1 plus 20, and it must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So in total, we have found out that according to equation 3, 3x1 plus 20 equals to minus x1. Here we add x1 to this equation, equation 3. We get that 3x1 plus x1 is 4x1 plus 20 equals to 0. Here we subtract 20 from this equation, equation 3, and get that according to this equation, equation 3, (4x1) equals to minus 20. So here we divide this equation, equation 3 by 4, and get that x1 equals to minus 20 over 4 is minus 5. So she found out that the coordinate x of this point B, x1 equals to minus 5. What is the value of coordinate y of this point B? This is y1. According to equation 2, y1 equals to minus x1. So y1 equals to minus x1, and x1 is minus 5. So in total, if you found out that y1 equals to minus 5, that is plus 5. So y1 equals to 5. So the coordinate b of this, the coordinate y of this point B, y1 equals to 5. So in total, if you found out that the coordinates of point B are minus 5 and 5. In the next step, I present to you the formula that gives us the distance between 2 points, and we use the formula in order to find out the distance between points A and B. The distance between points A and B is also the length of side AB of this right triangle ABO. Likewise, we use the new formula in order to find out the distance between those 2 points and O. And the distance between points A and O is also the length of this side AO of this right triangle ABO. And then the area of the green shape, this is actually the area of this green triangle ABO, will be equal to the base AB times the height AO over 2. So first of all, I present you the formula that gives us the distance between any 2 points. So in this drawing, we find out the distance between those 2 points Q and P. And because of the fact that points Q and P could be any 2 points, the formula that we will find will be good for any for the distance between any 2 points. The coordinates of point Q are x2 and y2. The coordinates of this point P are x1 and y1. So in the drawing we have this green right triangle QPR. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this right triangle QPR, QP squared, that is the square of the hypotenuse, equals to PR squared plus QR squared. And this green right triangle PQ1, QP squared, that is the square of the hypotenuse, equals to PR squared plus QR squared. PQ squared equals to PR squared plus QR squared. PQ is the missing hypotenuse, so we leave it as it is, so it is PQ squared equals to PR squared. PR equals to x2 minus x1, and therefore PR squared equals to x2 minus x1 squared. PR squared equals to x2 minus x1 squared. And here plus QR squared. QR equals to y2 minus y1, and therefore QR squared equals to y2 minus y1 squared. So in total, if you want to know that PQ squared equals to x2 minus x1 squared plus y2 minus y1 squared. Here we take out of the equation and find again that the distance between those 2 points P and Q, that is also the length of the hypotenuse PQ, equals to the square root of x2 minus x1 square plus y2 minus y1 square. So we use the new formula in order to find out the distance between those 2 points A and B. This is the straight line AB that is coming from the original drawing. We define the coordinates of this point B as x2 and y2. x2 equals to minus 5, and y2 equals to 5. Likewise, when you find the coordinates of this point A, it's x1 and y1. x1 equals to 2 and y1 equals to minus 6. We use the new formula in order to find out the distance between those 2 points A and B. According to the new formula, the distance between point A and B is also the length of line segment AB. So AB in total will be equal to, according to the new formula, will be equal to the square root of x2 minus x1 square plus y2 minus y1 square. So AB equals to the square root of x2 minus x1 squared. x2 is minus 5 minus x1. x1 is 2, so it is actually minus 5. Actually here x1 equals to minus 6. The coordinate x of this point A is minus 6, so x1 equals to minus 6. Coordinate y of this point A, y1 equals to 2. So according to this new formula, AB equals to x2 minus x1. So it is x2 is minus 5 minus x1 is minus 6 squared. And we have plus y2 minus y1 squared. So it is plus y2 is 5 minus y1 is 2 squared. So AB equals to the square root of minus 5 minus 6 is minus 5 plus 6, that is 1, and 1 square is 1. Plus 5 minus 2 is 3, 3 square is 9. So in total, inside the root we have 1 plus 9, that is 10. So if you found out that AB equals to the square root of 10 units in its length. The distance between points A and B is equal to the square root of 10 units in its length, and the distance between points A and B is also the length of side AB of this right triangle AB also. AB equals to the square root of 10 units in its length. Likewise, we find out the distance between points A and O according to the new formula, and the distance between points A and O is also the length of side AO of this right triangle ABO. The distance between points A and O is equal to the square root of x2 minus x1 square plus y2 minus y1 square. So I'll copy the straight line AO in a new page. This is the straight line AO that I copied from the original drawing. we define the coordinates of point A as x2 and y2. So the coordinate x of point A is x2, that is equal to minus 6, and the coordinate y of point A is y2, that is equal to 2. Likewise, we define the coordinates of this point O as x1 and y1. The coordinate of x of point O is x1, that equals to 0, and the coordinate y of point O is y1, that also equals to 0. So according to the new formula, the distance between points A and O is as follows. AO equals to the square root of x2 minus x1 squared. x2 is minus 6, minus x1 is also minus 6, minus 0 is minus 6, and minus 6 squared is 36. So in total, x2 minus x1 squared equals to 36, plus y2 minus y1 squared. y2 is 2, y1 is 0, so 2 minus 0 is 2, and 2 squared is 4. So in total, y2 minus y1 squared equals to 4. So AO, inside the root we have 36 plus 4, that is 40. So in total, we should find out that the distance between those 2 points A and O is equal to the square root of 4 units in its length, and the distance between those 2 points A and O is also the length of line segment AO. But again, we should find out that the length of this line segment AO is equal to the square root of 40 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? The green shape is actually the green rectangle BAO. So actually our test is to find out the area of the green rectangle BAO. Again, because of the fact that the green shape is the green rectangle BAO, our test is to find out the area of the green rectangle BAO. Actually, we know that the area of any triangle equals to the base of the triangle times the height over 2. Therefore, the area of this green rectangle ABO will be equal, we choose the base of this green rectangle ABO as AB. The height is AO. Why the height is AO? Because it's greater than 90 with the base AB. The height is AO over 2. So in total, we should find out that the area of the green shape, that is the area that we're looking for in this question, equals to the base AB times the height AO over 2. But we already found out that AB equals to the square root of 10, and AO equals to the square root of 40 divided by 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20, and 20 over 2 is 10. So in total, we found out that the area that we are looking for this question, that is the area of the green shape, in total is equal to the square root of 10 units in its length, in its size. It's equal to the square root of, it is equal to 10 square units in size. And again, the area that you're looking for in this question, that is the area of this green shape, equals to 10 square units in its size. So we finished with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. Because of the fact that those three squares are identical, all the sides of all those squares must be equal to 2 because one side is 2. This is a square, and therefore all the angles inside the square are right angles. So this is a right angle, and this is also a right angle. Likewise, this is also a square, and therefore this is a right angle, and this is also a right angle. In the next step, we will define the relevant points to the equation with letters. We define this point as A, this point as B, this point as G, and this point as H. So, in the big quadrangle ABGH, we have 4 right angles, and therefore we can relate to the big quadrangle ABGH as a rectangle. So as you know, the big quadrangle ABGH is a rectangle because it has 4 right angles. But you also know that the opposite sides of a rectangle are parallel to each other. So in the big rectangle ABGH, side BG is parallel to the opposite side AH. BG is parallel to AH. So in the next step, we'll extend those two parallel lines by a straight line. When you extend two parallel lines by a straight line, the result must be also, the extended parallel lines must be also parallel to each other. So those two extended parallel lines must be also parallel to each other. In the next step, we will do a construction. That is to say, we will make perpendicular on this side in such a way that it will pass for this point. So we define this point as point F. And again, we will draw perpendicular on this straight line in such a way that the perpendicular will pass from point F. That is the vertex of this right triangle AGF. So actually, this angle equals to 90 degrees according to our construction. We will define the touching point of the extended perpendicular with this side. This point is point D. We will define this point as point C. By doing this construction, we can do the big quadrilateral ABCD. Inside this big quadrilateral ABCD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Another reason that this fourth missing angle must be equal to 90 degrees is because of the fact that side BC is parallel to side AD. Why? Because we extended two parallels by side line, and therefore the result BC and AD must be also parallel to each other. So those two sides are parallel to each other, and those two angles are defined as one-sided interangles, and they are located between those two parallels. And therefore the sum of those two one-sided interangles must be equal to 180 degrees. But this angle equals to 90 degrees according to our construction, and therefore this missing angle must be also equal to 90 degrees according to the rule that I mentioned. So I presented to you two reasons that this fourth missing angle must be equal to 90 degrees in its size. So inside the big quadrilateral ABCD we have 4 angles, and therefore can relate to this big quadrilateral ABCD is a rectangle. Write it down. In the next step, we will define this angle AGB, as alpha. CB is one side of rectangle ABCD. Repeat again, CB is one side of rectangle ABCD, therefore it is absolutely a straight line. So if you focus on the right side, of the straight line CB at point G here, the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line CB at point G? You have this angle is equals to alpha, plus this is a right angle according to what is given as the question, plus this third missing angle, this is actually angle CGE, in total the sum of those three angles must be equal to 180 degrees according to all three. Repeat again. If you focus on the right side of the straight line BC at point G, the sum of the angles must be equal to 180 degrees according to rule 3. So the angles that we have at the right side of the straight line of the second BC point G are alpha 90 degrees and the first BC angle CG. And according to Olympiad, the sum of those three angles must be equal to 180 degrees. So that is to say alpha plus 90 degrees plus the third BC angle CG in total must be equal to 180 degrees. Here we subtract 90 degrees from this equation and we get that alpha plus the BC angle CGE in total equals to 180 degrees minus 90 degrees, it is 90 degrees. So in total, if we found out that alpha plus the missing angle CGE equals to 90 degrees. Here we subtract alpha from this equation. We find that the missing angle CGE is equal to 90 degrees minus alpha. This is the missing angle CGE, that is equals to 90 degrees minus alpha. Likewise, in this right lower triangle GBA, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. According to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we will prove that those two right triangles are similar to each other according to angle similarity rule. This is why we prove that this is the upper right triangle CFG that is similar to this right lower triangle GBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees and therefore they are equal to each other. But before that, in this upper right triangle CFG, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. Therefore this first angle must be equal to alpha. So in the next step, we prove that those two right triangles are similar to each other according to angle similarity rule. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees and therefore they are equal to each other. In addition, both those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to alpha and therefore they are equal to each other. So if you found out that all the figures of this right upper triangle CFG are closely equal to all the figures of this right lower triangle GBA, and therefore those two right triangles are similar to each other according to angle similarity rule. So write it down. This is the right triangle CFG. And it is similar, this is the sign of similar, to this right lower triangle GBA. According to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side GB of this right lower triangle GBA over side CF of this upper right triangle CFG is equal to side BA of this right lower triangle, triangle GBA, over side CG of this upper right triangle, triangle CFG. And again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side GB of the right lower triangle, triangle BGA, or side CF of the right upper triangle CFG is equal to side BA of the right lower triangle, triangle GBA, or side CG of the upper right triangle CFG. GB is 2 according to what is given in the equation, or CF. CF is the missing side, so we leave it as it is. And it is equal to BA. BA in total is 6 over CG. CG is the missing side, so we leave it as it is. So in total, if you found out that 2 over CF equals to 6 over CG. Here we first multiply this equation. And we get that 2 times CG equals to 6 times CF. Here we divide this equation by 2. And finally, we get that 2 CG over 2 is CG equals to 6 CF over 2 is 3 CF. So in total, if you found out that CG equals to 3 times CF. So if we define CF as X, then according to this equation, CG must be equal to 3X. So if CF is X, then CG must be equal to 3X. In the big rectangle ABCD, side CB must be equal to the opposite side DA. But CB in total is 3x plus 2, therefore the opposite side DA must be also equal to 3x plus 2 in its length. So DA equals to 3a plus x. DA equals to 3x plus 2. This is equals to 3x plus 2. We have the rule that says that the diagonals of a square bisects the angle of the square. But again, we have the rule that says that the diagonals of a square bisects the angles of the square. So this square and this square, this diagonal bisects this angle. So each half must be equal to 45 degrees in its size. So in this big right triangle ADF, this angle equals to 45 degrees, this angle equals to 90 degrees. 45 degrees plus 90 degrees is 135 degrees, so 135 degrees plus the size of this third missing angle, in total must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. And therefore this third missing angle must be equal to 45 degrees in its size. We have also the rule that said that in front of equal angles in the triangle there are equal sides. Again, in front of equal angles in the triangle there are equal sides. So in this big right triangle FDA, in front of those two equal angles, we have those two sides that must be also equal to each other and their lengths. So in the right triangle FDA, side FD must be equal to the opposite side DA. And again, in this right triangle FDA, and side FD must be equal to side DA. FD equals to DA. What is the left of line side FD? FD equals to CD minus CF. Again, FD equals to CD minus CF. So you know FD in total equals to CD minus CF. So FD in total equals to CD, that is 6, according to the rule. The opposite sides of a rectangle are equal to each other. The big rectangle ABCD, side AB equals to the opposite side CD. But AB is 6, therefore the opposite side CD must be also equal to 6 units in its length. So again, CD is 6, CF is x. So again, CD is 6 minus CF, that is x. So in total, we found out that the missing line segment FD is equal to 6 minus x units in its length. So we already found out that FD equals to DA. But FD equals to 6 minus x, so you can write here that FD equals to 6 minus x. And for this equation, 6 minus x equals to FD equals to DA. We derive that DA must be also equal to 6 minus x units in its length. So DA from one side is equals to 6 minus x. But from the other side, we already found out that DA also equals to 3x plus 2. So you can write that DA equals to 3x plus 2. And for this equation, so those two sides of the equation are equal to each other. That is to say, 3x plus 2 equals to 6 minus x. So here we let x to this equation. If we get that 3x plus x is 4x plus 2 equals to 6. So here we subtract 2 from this equation. If we get that 4x equals to 6 minus 2 is 4. 4x equals to 4. Here we divide this equation by 4 and we get that 4x over 4 is x, and it equals to 4 over 4 is 1. So in total, we should found out that x equals to 1 unit in its length. So here, CF equals to x, and therefore x equals to 1. This is to say, CF equals to 1. Likewise, we already found out that CG equals to 3x, and x is 1. X is 1, so 3x equals to 3 times 1, that is 3. CG equals to 3 units in its length. In the next step, we implement the Pythagoras theorem on this right triangle CFG. Here by PT is a version from Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle CFG, according to the Pythagoras theorem, FG squared, that is the square of the hypotenuse, equals to CF squared plus CG squared. And again, this right triangle CFG, according to the Pythagoras theorem, FG squared, that is the square of the hypotenuse, equals to CF squared plus GF squared. Again, it equals to FG squared equals to CF squared plus CG squared. FG squared, that is the square of the hypotenuse, equals to CF squared plus CG squared. FG is the missing side, so we leave it as it is, so it is FG squared equals to CF squared. CF is 1, therefore CF squared is 1 squared, that is 1. Plus CG squared. CG is 3, therefore CG squared is 3 squared, that is 9. So in total, if you found out that FG squared equals to 1 plus 9, that is 10. FG squared equals to 10. Here we take out of the equation, finding that FG equals to the square root of 10 units and its length. So the length of the hypotenuse is FG of the right triangle FCG is equal to the square root of 10 units in its length. Likewise, we implement the Pythagoras theorem on this right lower triangle, triangle GBA. Here by PT is the version for Pythagoras theorem. This right lower triangle, triangle GBA, GA squared, that is the square of the hypotenuse, equals to GB squared plus BA squared. And again, this right lower triangle GBA GA squared, that is the square of the hypotenuse, equals to GB squared plus BA squared. The hypotenuse GA is the missing side, so we leave it as it is, so it is GA squared equals to GB squared. GB is 2, therefore GB squared is 2 squared, that is 4, plus BA squared. BA in totality is 6, and therefore BA squared is 6 squared, that is 36. So in total, we have found out that GA squared equals to 4 plus 36, that is 40. GA squared equals to 40. Here we take out of this equation, finding that the missing hypotenuse GA is equal to the square root of 40 units in itself. So this is the method of hypotenuse GA that equals to the square root of 40 units in its length. Our task is to find out the area of this grand shape. The grand shape is actually the grand angle FGA, so our task is to find out the area of the grand angle FGA. But we know that the area of any triangle equals to the base of the triangle times the height over 2. The base of any triangle equals to the base of the triangle times the height over 2. We choose the base of this grand angle GFA as GF. And the height is AG. Why the height is AG? Because of the fact that AG creates an integral with the base FG over 2. So in total, we actually found out that the area of the grand shape, that is the area that we're looking for in this question, is equals to the base GF times the height AG over 2. We have already found out that GF equals to the square root of 10 units in its length times the height AG. AG equals to the square root of 40 units in its length divided by 2. And square root of 10 times square root of 40 is square root of 400. Over 2. The square root of 400 is 20 and 20 over 2 is 10. So there the grand shape according to the second method is equal to 10 square units in its size. So in both methods, found out that the area of this grand shape is equal to 10 square units in its size. So we finish with the second method. In the next step, we summarize the lectures, that is to say, we repeat on the solution of the first method and then repeat on the solution of this second method. So in the drawing we have three identical squares. The side of one square is equal to 2, therefore the sides of all the other squares must be also equal to 2 because they are identicals. In addition, we have this green shape. This is actually the green right triangle, and our task is to find out the area of this green right triangle. Repeat again, because we found that those three squares are identicals, and this side is 2, therefore all the other sides must be also equal to 2. In the next step, I defined two concepts. The first concept is the Cartesian coordinate system, and the second concept is the slope of a straight line. So what is the Cartesian coordinate system? We know that the plane has two dimensions, the horizontal dimension and the vertical dimension. In the Cartesian system, the horizontal dimension is represented by the x-axis, the vertical dimension is represented by the y-axis. The intersection point between the x-axis and y-axis, this point is defined as the origin. The origin is the starting point of both axes. Therefore, the coordinates of point O is 0, 0. The origin is 0, 0. Every point in the plane is represented by two numbers. The first number represents the horizontal distance of the point from the origin. For example, we take this point, point A. The first number is the horizontal distance of point A from the origin O. This is the horizontal distance of point A from the origin O. So it is minus 3 minus 0. Minus 3 minus 0 equals to minus 3. So the first number is minus 3. And the second number is the vertical distance of point A from the origin O. The vertical distance of this point A from the origin O is this distance, is actually minus 1, minus 0 is minus 1. So the second number equals to minus 1. And the second concept is the slope of a straight line. In geometry, the slope of a straight line describes the intensity of its steepness. Again, the slope of a straight line describes the intensity of its steepness. A large value of the slope indicates a large steepness, and the slope of a straight line defined as the ratio of the vertical difference between 2 points on the straight line to the horizontal difference between those 2 points. This is the straight line. Those 2 points A and B are located on this straight line. The coordinates of this straight line A are x2 and y2, and the coordinates of this point, again, the coordinates of this point A are x2 and y2, and the coordinates of this point B are x1 and y1. And the slope of this straight line, the slope m, equals to the vertical distance, the vertical difference between those 2 points. What is the vertical difference between those 2 points? It is actually y2 minus y1 over the horizontal difference between those 2 points. What is the horizontal difference between those 2 points? It's actually x2 minus x1. So the ratio between the vertical difference and the horizontal difference equals to the slope of this straight line. We have another equation for a slope of a straight line. This is a straight line, and this is the positive x-axis. The angle that this straight line creates with the positive x-axis is this angle, theta. And the slope of this straight line equals to the tangents of the angle that this straight line creates with the positive x-axis, that is to say theta. So the slope of this straight line m equals to tangents theta. If the slope of a straight line is a positive slope, then it rises from the left side to the right side. Likewise, if the slope of a straight line is a negative slope, then it falls down from the left side to the right side. Likewise, if the slope of a straight line equals to 0, then the straight line is parallel to the x-axis. And another definition of a slope is the slope of a straight line is the constant rate of change for a straight line. Again, the definition of a slope is the constant rate of change for a straight line. So the slope of a straight line indicates how many units the line goes up or down. For each unit it moves right. For example, the function of this straight line, or the equation of this straight line, is y equals to 3x. So the slope of this straight line is 3. What is the meaning of slope 3? If we move 1 unit to the right side, that is to say from point 1 to point 2, then the function, the straight line, goes up 3 units. Why? Because if y equals to 1, if x equals to 1, then y equals to 3. And when we move 1 step to the right, then x equals to 2. And if x equals to 2, then y equals to 6. So when we moved 1 step to the right side, the straight line goes up 3 steps. Again, when we move 1 step to the right side, then the straight line goes up 3 steps. Therefore, the slope of this straight line is 3. And the greater the slope of the straight line, the steeper it is. Again, the greater the slope of the straight line, the steeper it is. This is a straight line. The slope of this straight line is 3, and the slope of this red straight line is third. and the stiffness of this straight line is greater than the stiffness of this red straight line. Why? Because of the fact that the slope of this straight line is greater than the slope of this red straight line. What is the meaning of stiffness? Means that this straight line, the blue straight line with greater stiffness, is farther from the x-axis than this red straight line. Why? Because of the fact that its slope is greater than the slope of this red straight line. Therefore, its stiffness is greater than this red straight line. That is to say, it is farther from this red straight line to the x-axis. In the next step, we created the Cartesian coordinate system in our drawing. We define this straight line as the x-axis, and this vertical straight line as y-axis. The intersection point between x-axis and y-axis, this is point O, that is the origin. The origin is the starting point of both axes, and therefore the coordinates of point O, the origin is 0, 0. So, in the next step, we define this point as point A. What are the coordinates of point A? The coordinate x is the horizontal difference between point O and the origin. The horizontal difference between point A and the origin O is this distance. This distance is 2 plus 2 plus 2 is 6. But because of the fact that this is the negative x-axis, this point is minus 6. This is the positive x-axis. Likewise, the coordinate y is the distance, the vertical distance of point A from the origin O. The vertical distance of point A from O is 2, because this line segment is 2. And this area is the positive y-axis, therefore the coordinate y equals 2, 2. So in total, the coordinates of point A are minus 6 and 2. Then we define this point as point B. We don't know the coordinates of point B, so we define the x coordinate of point B as x1 and the y coordinate of point B is y1. In the next step, we calculated the slope of this straight line BO. According to the formula that says that the slope of a straight line is the tangent of the angle that the straight line creates with the positive x-axis. The tangent of, but here we have this diagonal bisect this angle according to the rule that says that diagonals of a square bisect its angles. So this diagonal bisect this angle. So the first half is 45 degrees, and the second half is also 45 degrees. We also know that the axes intersect with each other at 90 degrees. So this is the right angle. 45 degrees plus 90 degrees, is 135 degrees. So the angle that the straight line BO creates with the positive x-axis is 135 degrees. Therefore, the slope of this straight line BO equals to, the slope M equals to times 135 degrees. And again, the slope of the straight line BO, the slope M equals to times tangent 135 degrees, that is minus 1. And again, the slope of this straight line BO equals to minus 1. And because of the fact that the slope of this straight line BO is a negative, it falls down from the left side to the right side. point O is located on the straight line below. Again, point O is located on the straight line O. So use the new formula in order to find out the equation of this straight line BO. The formula is y minus y1 equals to m times x minus x1. x1 and y1 is a point on the straight line itself. Point O is located on the straight line BO, so for x1 equals to 0 and y1 equals to 0. Again, and the slope of this straight line BO is minus 1. And again, x1 equals to 0, y1 equals to 0, and the slope of the straight line BO is minus 1. So we just have to put the data of this specific straight line BO inside this general formula for a straight line, and this way we find out the equation of this straight line BO. We did it and we found out that y minus y1. So it is y minus 0 is y equals to m is minus 1. Inside the brackets we have x minus x1. x1 is 0, so it is x minus 0 is 0. Again, y minus 0 equals to minus 1 times x minus 0. So y minus 0 is y equals to minus 1 times x. Minus 1 times x is minus x. So in total, we have found out that y equals to minus x. The equation of this straight line BO is y equals to minus x. The next step, we calculated the slope of this straight line AO. Because of the fact that points A and O are located on the straight line AO, we use the other formula for a slope in order to find out the slope of this straight line AO. The coordinates of those two points A and O are known, therefore we can use the other formula in order to find out the slope of this straight line AO. This is the straight line AO that is coming from the original drawing. The coordinates of point A are minus x and 2. So we define minus x, minus 6. The coordinates of point A are minus 6 and 2. So we define the coordinate x of this point A as x2. x2 equals to minus 6. And the coordinate y of this point A is 2. y2 equals to 2. Likewise, we define the coordinates of this point O, that is the origin, now 0, 0, x1 equals to 0, and y1 also equals to 0. We have the equation that says that the slope of a straight line equals to the vertical difference over the horizontal difference between those 2 points A and O. The vertical difference between those 2 points A and O are y2 minus y1. And the horizontal difference between those 2 points A and O is x2 minus x1. y2 minus y1, y2 is 2, minus y1 is 0. So it is 2 minus 0, that is 2. Over x2 minus x1. x2 is minus 6, minus x1 is 0, so x2 minus x1 is minus 6 minus 0, that is minus 6. Here we divided both the numerator and the denominator of this number by 2. 2 over 2 is 1, and minus 6 over 2 is minus 3. So in total, we found out that the slope of this straight line AO equals to minus third. And because of the fact that the slope of this straight line is a negative, the function and the straight line falls down from the left side to the right side. So the slope of this straight line AO equals to minus third. The slope of this straight line AB is unknown, so we define the slope of this straight line AB as M2. Because of the fact that the straight line AB is perpendicular to the straight line AO, we can implement here rule 12. According to rule 12, if two straight lines are perpendicular to each other, then the product of their slopes equals to minus 1. AB is perpendicular to AO, therefore the product of their slopes, it is M2 minus third equals to minus 1. according to rule 12, because of the fact that those two straight lines are perpendicular to each other, the product of their slopes must be equal to minus 1. That is to say, m2 times minus 1 equals to minus 1, according to rule 12. Here we multiply this equation by minus 1, so minus m2 over 3 times minus 1 is m2 over 3, minus 1 times minus 1 is 1, so in total m2 over 3 equals to 1. Here we multiply this equation by 3 and find out that m2 equals to 3 units in its length. That is to say, the slope of this straight line AB equals to 3. And because of the fact that the slope of this straight line is a positive, the functions goes up from the left side to the right side. So, in the next step, we calculated the equation of this straight line AB. The coordinates of point A are minus 6 and 2, and point A is definitely located on the straight line AB, and the slope of the straight line AB is 3. So we can definitely find out the equation of this straight line AB according to the formula that says that y minus y1 equals to m times x minus x1. x1 is minus 6, y1 is 2, m is 3. So we have all the data that is needed in order to find out the equation of this straight line AB. So y minus y1, this y1 is 2, so it is y minus 2 equals to m. M is 3. Inside the brackets we have x minus x1. x1 is 0. x1 is 0, so it is x minus 0. x1 is minus 6. x1 is minus 6, so it is x minus 6. So we have in this side of the equation y minus 2 equals to m is 3. So inside the brackets we have x minus 6 is x plus 6. So in total we should find out that y minus 2 equals to 3 times x plus 6. So y minus 2 equals to, we open the brackets here, 3 times x is 3x and 3 times 6 is 18. So in total we should find out that y minus 2 equals to 3x plus 18. Here we added 2 to this equation and finally found out that y equals to 3x plus 20. Y equals to 3x plus 20. So the equation of this straight line AB is y equals to 3x plus 20. Point B is a common point that belongs to both straight lines. Point B belongs to the straight line AB, and point B also belongs to the straight line OB. And we have the rule that says that if a point is located on the straight line, then the point must satisfy the equation of the straight line. Again, if a point is located on the straight line, then it must satisfy the equation of the straight line. Point B is located on the straight line BA, and therefore it must satisfy the equation of the straight line BA. That is to say, y1 equals 3x1 plus 20. We substitute x by x1 and y by y1. Then the left side of the equation must be equal to the right side of the equations. So according to equation 1, y1 equals to 3x1 plus 20. Likewise, because of the fact that point B is also located on the straight line BO, it must satisfy the equation of the straight line BO. That is to say, y1 equals to x minus x1. According to equation 2, y1 equals to minus x1. So we have two equations for y1, so therefore we created equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x1 plus 20. It must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So in total according to equation 3, we should find out that 3x1 plus 20 equals to minus x1. Here we did x1 to this equation. When we found out that 3x1 plus x1 is 4x1 plus 20 equals to 0. Here we subtracted 20 from this equation. When we found out that 4x1 equals to minus 20. Here we divided this equation 3 by 4, and when we found out that x1, 4x1 over 4 is x1, equals to minus 20 over 4 is minus 5. So we found out that the coordinate x of this point B, x1 equals to minus 5. What about the coordinate y? This is y1. According to equation 2, y1 equals to minus x1. So y1 equals to minus x1. x1 is 5. So y1 equals to minus 5, that is 5. So the coordinate y of this point B, y1 equals to 5. So in total, the coordinates of point B are minus 5 and 5. In the next step, I presented to you a new formula that gives us the distance between any 2 points. Okay, and we implemented the new formula in order to find out the distance between points A and B, and we found out also the distance between points A and O. The distance between points A and B is the length of side AB. This triangle, the distance between points A and O is the length of this side AO of this triangle, and the area of the green shape, the area of this green triangle, is equal to the base AB times the height AO over 2. So here we found out the distance between points P and Q. And because of the fact that points P and Q could be any points, this formula, it is good for the distance between any 2 points. So in the drawing we have this green triangle PQR. So we can implement here the Pythagoras theorem. According to the Pythagoras theorem, in any triangle the square of the hypotenuse equals to the sum of the slope of the perpendiculars. This green triangle PQR, PQ squared, that is the square of the hypotenuse, equals to PR squared plus QR squared. Again, in this triangle PQR, according to the Pythagoras theorem, PQ squared equals to PR squared plus QR squared. PQ is the missing hypotenuse, so we limit it as it is. And it's equals to PR squared. PR, from the drawing, it is very easy to see that PR in total equals to x2 minus x1, therefore PR squared equals to x2 minus x1 squared. So in total, PR squared equals to x2 minus x1 squared plus QR squared. QR equals to y2 minus y1. Therefore, QR squared equals to y2 minus y1 squared. So in total, we found out that PQ square equals to x2 minus x1 square plus y2 minus y1 square. Here we took a root out of this equation and we found out that the distance between points P and Q, this is also the length of the hypotenuse, PQ equals to the square root of x2 minus x1 square plus y2 minus y1 square. And use the new formula in order to find out the distance between those 2 points A and B. So copy this straight line AB in Olympiad. This is the straight line B8 that is copied from the original drawing. The coordinates of point B are minus 5 and 5. So we define the coordinate x as x2 and the coordinate y, that is 5, as y2. So x2 equals to minus 5 and y2 equals to 5. Likewise, the coordinates of this point A are 2 and minus 6. So we define the coordinates x of this point A as x1 and the coordinate y of this point A is y1. And then use the new formula in order to find out the distance between those 2 points A and B. According to the new formula, the distance between those 2 points A and B is equal to the square root of x2 minus x1 square plus y2 minus y1 square. So the distance between points A and B, this is also the length of right side AB, is equal to x2 minus x1 square. x2 is minus 5 and x1 is, again, x1 is a mistake. The coordinates of point A is minus 6 and 2. So here x1 equals to minus 6 and y1 equals to 2. So here we have x2 minus x1 squared. So x2 is minus 5 minus x1. x1 is minus 6. So x2 minus x1 is minus 5 minus 6. Is minus 5 minus 6. And minus 5 minus 6 is minus 5 plus 6, that is 1. And 1 squared is 1. So in total, we should find out that x2 minus x1 squared equals to 1. Likewise, we have also plus y2 minus y1 squared. y2 is 5, minus y1 is 2, 5 minus 2 is 3, and 3 squared is 9. So in total, we should find out that y2 minus y1 squared equals to 9. 1 plus 9 is 10. So in total, we should find out that the length, the distance between points A and B is equal to the square root of 10 units in itself, and the length of line segment AB is equal to the square root of 10 units in itself. Again, we should find out that the length of this straight line AB, this right here, is equal to the square root of 10 units in itself. Likewise, we calculated the distance between those 2 points A and O. So call this straight line A1 and A and we use the new formula in order to calculate the distance between those 2 points A and O. This is point A. We define the coordinates of point A as x2 and y2. Likewise, we define the coordinates of this point O, that is the origin, as x1 and y1. So if x2 equals to minus 6, y2 equals to 2. Likewise, if x1 equals to 0 and y1 equals to 0. We use the new formula in order to find out the distance between points A and O. According to the new formula, the distance between points A and O is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So it is equals to x2 is minus 6, minus x1 that is 0. Minus 6 minus 0 is minus 6, and minus 6 squared is 36. So in total, x2 minus x1 squared equals to 36. Plus y2 minus y1 squared. y2 is 2, minus y1 is 0, 2 minus 0 is 2, and 2 squared is 4. So in total, y2 minus y1 squared equals to 4. Inside the root we have 36 plus 4 is 40. So in total, we should find out that the distance between points A and O is square root of 40, and the length of line segment AO equals to the square root of 40 units in its length. That is to say, the length of this side AO of this green rectangle is equal to the square root of 40 units. Our task was to find out the area of this green shape. Because of the fact that the green shape is the green rectangle BAO, our test was to find out the area of this green rectangle BAO. Our test was to find out the area of the green rectangle BAO. But we know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base as BA or AB, the height is OA, where the height is OA because it's less than 3, but the base AB. So the height is AB, the base is AB, the height is AO over 2. The base is AB, the height is AO over 2. We only found out that AB equals to the square root of 10, AO equals to the square root of 40 over 2. Square root of 10 times square root of 40 is square root of 400 over 2. Square root of 400 is 20, and 20 over 2 is 10. So in total, we have found out that the area that we're looking for in this equation, that is the area of this green shape, is equal to 10 square units in its size. So we finish to repeat on the first method. In the next step, repeat on the solution only to the second method. So in the drawing we have 3 identical squares. The length of one side is 2, the length of other sides must be also equal to 2. And this is a square. therefore those two angles are right angles. Likewise, this is a square, and therefore those two angles are also equal to 90 degrees in their sizes each one. In the next step, we define the relevant points to this equation with letters. We define this point as A, this point as H, this point as B, this point as G, this point as F. So, in the big quadrilateral GHAB, we have 4 right angles, and therefore we can relate to this quadrilateral GHHB as a right angle. Okay. But we also know that the opposite sides of a rectangle are parallel to each other. So in the big rectangle GHAB, side AH is parallel to the opposite side BG. Then we extended those two parallels by side line. The result must be also two parallels. We extend two parallels by side line. The result, the extended parallels must be also parallel to each other. So BC is parallel to AD. In the next step, we did the construction, that is to say, we draw perpendicular on this side BC in such a way that the perpendicular will pass for point F. It is definitely possible because along the straight line CB, you can do infinite perpendiculars. You can draw infinite perpendiculars on this straight line CB. One of the perpendiculars will definitely pass for point F. Okay? And we find the turning point of the perpendicular with this straight line. This point is point C. So this angle equals to 90 degrees according to our construction. Then we extended the perpendicular by straight line until it touches this side. We define the touching point of the extended perpendicular with this side. This point is point D. By doing this construction, we're going to do a quadrilateral ABCD. Inside the big quadrilateral ABCD, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to our construction. So in total, in this quadrilateral, we have 3 right angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this fourth angle, in total must be equal to 360 degrees. According to the rule that says that the sum of the angles in quadrilateral is equal to 360 degrees. And therefore, this fourth angle must be equal to 90 degrees in its size. Second reason that this fourth angle must be equal to 90 degrees in its size is because of the fact that we know that BC is parallel to AD. Those two angles are both defined as one-sided interangles, and because of the fact that those two one-sided interangles are located between those two parallels, the sum of those two one-sided interangles must be equal to 180 degrees. But this angle equals to 90 degrees according to our construction. Therefore, this missing angle must be also equal to 90 degrees in its size according to the rule that I mentioned. So I presented to you two reasons that this fourth angle must be equal to 90 degrees in size. So in total, inside the big quadrilateral ABCD, we have 4 right angles. Therefore, can relate to the big quadrilateral ABCD is a right angle. But we also know that the opposite sides of a rectangle are equal to each other. So in the big rectangle ABCD, side AB must be equal to the opposite side CD. But AB is 6, and therefore the opposite side CD must be also equal to 6 units in its length. In the next step, we define this angle AGB as alpha. CB is one side of rectangle ABCD, therefore it is absolutely a straight line. So if you focus on the right side of the straight line CB, here at point G, here the sum of the angles must be equal to 180 degrees according to all 3. All 3 said that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line CB at point G? We have this angle alpha plus this angle is right angle according to what is given in the question, plus this third missing angle, this is actually angle CGF. In total it must be equal to 180 degrees according to all 3. Repeat again, if you focus on the right side of the straight line BC at point G, the sum of the angles must be equal to 180 degrees according to all 3. That is to say, alpha plus 90 degrees plus the first missing angle CG in total must be equal to 180 degrees. If subtracted 90 degrees from the equation, you find out that alpha plus the missing angle CG equals to 180 degrees minus 1 degrees, this is 90 degrees. If subtracted alpha from the equation, you find out that the missing angle CG equals to 90 degrees minus alpha. This is the missing angle CGE, CGF, this equals to 90 degrees minus alpha. So in this triangle, right triangle GCF, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, it is the sum of the angles in any triangle. Likewise, in this lower right triangle GBA, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha, according to the same reason that said that the sum of the angles in any triangle is equal to 180 degrees. The next step, we prove that those two right triangles are similar to each other according to angle similarity rule. That is to say, we prove that this upper right triangle FCG is similar to this right lower triangle GBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So we should found out that all the figures of this upper right triangle CFG are possibly equal to all the figures of this lower right triangle GBA, and therefore those two right triangles are similar to each other according to angle similarity rule. So if it again, we should found out that the upper right triangle CFG is similar, this is the sign of similar, to the right lower triangle GBA according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side GB of this right lower triangle GBA, or side CF of this upper right triangle CFG is equal to side BA of this right lower triangle GBA, or side CG of this upper right triangle FCG. It again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side GB of the right lower triangle GBA, or side CF of the upper right triangle CFG is equal to side BA of the right lower triangle GBA, or side CG of the right lower triangle, or side CG of the upper right triangle CFG. GB is 2, CF is unknown, so we leave it as it is. BA in total is 6, and CG is the missing side, so we leave it as it is. So in total, we should know that 2 over CF equals to 6 over CG. Here we cross multiply this equation, and finally found out that 2 times CG equals to 6 times CF. Here we divide this equation by 2, finally found out that 2 times CG over 2 is CG, equals to 6 times CF over 2 is 3 times CF. In the end, total, we should find out that CG equals to 3 times CF. So if we define the length of CG and the length of this natural CF as x, then according to this equation, CG must be equal to 3x. Okay. So we define the length of this line CF as x, and therefore CG must be equal to 3x. So what is the length of this missing line segment? FD. FD equals to CD minus CF. Again, FD equals to CD minus CF. So if D equals to CD, that is 6, CD is 6, minus CF, that is x. So in total, the missing line segment the FD equals, the missing line segment FD equals to 6 minus x. We know that ABCD is a rectangle, and the opposite sides of a rectangle are equal to each other. So in the big rectangle ABCD, side CB must be equal to the opposite side DA. But CB in total is 3x plus 2, therefore the opposite side DA must be also equal to 3x plus 2 in its length. So in total, you should find out that DA equals to 3x plus 2. This is the diagonal of this square. The diagonals of a square bisect the angles of the square. This diagonal bisects this angle, so each arc must be equal to 45 degrees. So in the big right triangle FDA, this angle equals to 45 degrees, this angle equals to 90 degrees, 90 degrees plus 45 degrees, it is 135 degrees, so 135 degrees plus this angle, in total they must be equal to 180 degrees. According to the old, it said that the sum of the angles in any triangle is equal to 180 degrees. Therefore, this angle must be equal to 45 degrees in its size. we have the old that said that in front of equal angles in the triangle, they are equal size. Again, in front of equal angles in the triangle, they are equal size. So the big right triangle FDA, in front of those two equal angles, we have those two sides that must be equal to each other, their lengths. So in the right triangle FDA, FD equals to DA. Again, the right triangle FDA, FD equals to DA, according to the old dimensions. But we already found out that FD equals to 6 minus x, so you can idea that FD equals to 6 minus x, and from this equation, FD 6 minus x equals to FD equals to AD. We derive that AD must be also equal to 6 minus x units in its length. AD equals to 6 minus x. So from one side, AD equals to 6 minus x, and from the other side, AD equals to 3x plus 2. So those two sides of the equation are equal to each other. That is to say, 3x plus 2 equals to 6 minus x. Here we let x of this equation, if I found out that 3x plus x is 4x, so 4x plus 2 equals to 6. Here we subtract 2 from this equation, if I found out that 4x equals to 6 minus 2 is 4. Here we divide this equation by 4, and I found out that 4x over 4 is x, and it is equals to 4 over 4 is 1, so x equals to 1. This is side CF, this equals to x, and x equals to 1, so CF equals to 1. Likewise, CG equals to 3x, x equals to 1, so CG equals to 3 times 1, that is 3, so CG equals to 3. So in the next step, implement the Pythagoras theorem on this right upper triangle, triangle CFG. According to the Pythagoras theorem, FG square equals to CF square plus CG square. Okay, again, this upper right triangle CFG, according to the Pythagoras theorem, FG square, that is the square of the hypotenuse, equals to CF square plus CG square. FG is the missing hypotenuse, so we leave it as it is. And it is equals to CF square. CF is 1, therefore CF square is 1 square, that is 1, plus CG square. CG is 3, therefore CG square is square, that is 9. So in total, we should find out that FG square equals to 1 plus 9, that is 10. FG square equals to 10, here we took out of the equation, and found out that FG equals to the square root of 10 units in its length. The hypotenuse FG equals to the square root of 10 units in its length. Likewise, we implemented the Pythagoras theorem in this right lower triangle, triangle GBA. According to the Pythagoras theorem, this right triangle GBA, GA squared, that is the square of the hypotenuse, equals to GB square plus BA square. But again, this right lower triangle, triangle GBA, according to the Pythagoras theorem, GA squared, that is the square of the hypotenuse, equals to GB square plus BA square. GA is the missing hypotenuse, so we leave it as it is. And it is equals to GB square, GB is 2, therefore GB square is 4. 2 square is 4. Plus BC square, plus BA square. BA is 6, therefore BA square is 6 square, that is 36. So in total, we should find out that GA square equals to 4 plus 36, that is 40. GA square equals to 40. Here we took out of the equation, we found out that the missing hypotenuse GA equals to the square root of 40 units in its length. This is the missing hypotenuse GA, this equals to the square root of 40 units in its length. Our task is to find out the area of this green shape. The green shape is actually the green triangle FGA. So our task is to find out the area of this green triangle FGA. We have to find out the area of the green triangle FGA. We know that the area of any triangle equals to the base of that triangle times the height over 2. We choose the base of this green triangle FGA as FG, and the height is GA. Why the height is GA? Because it gets the address with the base FG. So the base is FG and the height is GA. Again, the base is FG and the height is GA divided by 2. GF equals to the square root of 10, and G equals to the square root of 40 divided by 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20, 20 over 2 is 10. So in both methods, we should find out that the area that we're looking about this equation, that is the area of this green shape, it is equals to 10 square units in its size. Repeat again, the area of this green shape on both methods, it is equals to 10 square units in its size. Okay? Thank you very much.